Hi dear students, welcome to our channel Exam Side Mathematics by Pani. Here we are going to discuss about relations and functions. We are in exercise 2D. This is the fourth video. I'll come back in 15-20 seconds. Hi dear students. Here the question from exercise 2D. The first question is f of x equal to x square and find f of 1.1 minus f of 1 divided by 1.1 minus 1. See, first you have to write given function f of x is equal to x square. Next, calculate the values of f of 1.1. So f of 1.1 which is equal to 1.1 whole square. Generally 11 square means 121, no? So 1.21. So next f of 1 which is equal to 1 square which is equal to 1. Now come to the question. Therefore f of 1.1 minus f of 1 divided by 1.1 minus 1. F of 1.1 value is 1.21 minus f of 1 value is 1. 1 means what? 1.00. According to the convenience of writing. 1.1 minus 1. So 1.1 minus 1 means 1.0 you have to write it. So 0.1. So which is equal to 0.21 divided by 0.01. So sorry, 0.1. Multiplying and dividing by 100. So it will become 21. It will become 10. 0.1 means 1 by 10. 1 by 10 into 100 is 10. So 10 by 21 by 10 is 2.1. So this is the final answer for the given question. Next question is find the domain and range of f of x equal to. So f of x equal to x square plus 2x plus 1 whole divided by x square minus 8x plus 12. So it is in the form of h of x by g of x. Whenever the given function f of x is of the form h of x by g of x, f of x is defined when g of x is not equal to 0. F of x is defined when g of x is not equal to 0. So accept that values. What is g of x in this? X square minus 8x plus 12 is not equal to 0. So for this factors x square minus 6x minus 2x plus 12 is not equal to 0. X into x minus 6 minus 2 into x minus 6 is not equal to 0. X minus 2 into x minus 6 is not equal to 0. So x is not equal to 2. X is not equal to 6. Except the values of 2 and 6, the function is going to define. Therefore, domain of f of x is r minus 2 comma 6, except the values of 2 and 6, the rest of the values the function is going to define. I hope you understand. We'll move to question number I think for question number 2, it's a range only. The range is not only domain. Sorry for the question, dear students. Here only domain of the function. Range is not given. So when range we already discussed in the quadratic equation, when the function is of the form rational function type. We already done that. Only domain. Now come to here, domain and range both are there. So f of x is equal to root x minus 1. Whenever it is in the form of root f of x or root g of x, is defined g of x can be greater than or equal to 0. That means x minus 1 is greater than or equal to 0 means x is greater than or equal to 1. So x belongs to closed 1 comma infinity. So that means in the real number line, so from 1 to infinity. So in between, including 1 and also on infinity. So the range, how to calculate it? So if you put x is equal to 1, that implies that y is equal to f of x will become 0. X is equal to 2, substitute y is equal to f of x equal to root 1. That means 1. X is equal to 2. That means, so from 1 onwards, 1, 2, 3 and so on infinity. So y is equal to f of x equal to root 2. So and so on up to infinity. So therefore the range of, these are the domain values, these are the range values. So range of f of x, a range of f of x. That means f suffix means range of f of x. It starts from what? 0. So close 0 to infinity. So this is the range of the function, this is domain of the function. Domain of the function df equal to closed 1 to infinity. Okay, dear students, I hope you understand. We'll move to other question. The question number 4. Find the domain and range. Domain and range of the real function f defined by f of x equal to root over x minus 1. This is the question. Next, similarly, not root over x minus 1 already completed. Mod x minus 1. Next, question number 5. From here we will start. Let f equal to x comma x squared by 1 plus x squared, where x belongs to R, be a function from R to R determine the range of f, determine the range of f. That the questions we will see. See here, find the domain of the function. If we take in place of x, any value of real number, if you take, it comes no answer. So, this is the modulus function. Domain of the modulus function is real numbers. The domain. Sorry for the interruption, guys. Domain of f of x is equal to real numbers. That means in real numbers, you know, from minus infinity to plus infinity, any values it comes. If you substitute the domain values in this range of f of x, if you take negative values from real numbers, here anyway it is modulus, it will become non-negative integers. Non-negative. Non-negative numbers. Okay, dear students, that's all. Domain is real numbers. In that, positive real numbers only will come, non-negative numbers means. Here they are asking to find a range of the function. So x, y. So let y is equal to x square by 1 plus x square cross multiply y plus x square y. Sorry, minus x square equal to 0. From these two, x square into y minus 1 plus y equal to 0. This you have to compare with ax square plus bx plus c. Here a equal to y minus 1, b equal to 0 and c equal to y. We know that a cannot be equal to 0, otherwise it is not a quadratic equation. So a cannot be equal to 0 means y minus 1 cannot be equal to 0. So minus 1 bring this side, y cannot be equal to 1. In the range itself, y cannot be. Later, since x is real, since x belongs to real number, since x belongs to R, then delta greater than or equal to 0. Delta means b square minus 4ac. That is b square minus 4ac greater than or equal to 0. B square means 0 minus 4 into a value y minus 1, c value y greater than or equal to 0. 4 bring this side, minus y into y minus 1 is greater than or equal to 0. 0 by 4 will come, dear students, here. If we remove minus, 0 by anything is 0. If we remove minus here, inequality will change. Y into y minus 1 is less than or equal to 0. So y minus 0 into y minus 1 less than or equal to 0. So whenever less than or equal to 0, y means y lies between 0 and 1. So y lies between 0 and 1. Or we can write like this. Y belongs to closed 0, 1. But this is not the right answer. Why? Here Here y cannot be equal to 1 means before 1 what should be there? So y cannot be there. Close 0, open 1. Since y cannot be 1, that is the reason this is the range of f of x. Range of f. So y belongs to close 0, open 1. I hope you understand this, students. We move to other question. Let R be the relation. Let R be a relation from n to n, natural numbers to natural numbers, denoted by R equal to A comma B ordered pair such that A comma B belongs to n and A is equal to B square. Are the following true? Are the following true? They are asking to find whether it is correct or not. So the first one, ordered pair A comma A belongs to R. For all A belongs to n. Second one, A comma B belongs to R implies B comma A belongs to R. Third one, A comma B belongs to R, B comma C belongs to R, then A comma C belongs to R. Justify your answer. Justify your answer. See, in what way we are going to give the justification, you need to understand, dear students, by taking some simple examples in our daily activity. See, for the first case, if you take that, A is equal to 1, but the relation is mentioned first, relation you have to write it. R is equal to ordered pair A comma B such that A comma B belongs to R, sorry, not N, natural numbers, N, and A equal to B square. This condition should follow. Okay, dear students. Now I am taking, let A is equal to 1, even B is equal to also 1, and A equal to B equal to 1 belongs to N, and 1 equal to 1 square, even this is also possible. But what about if you take A is equal to 2? A is equal to 2, B is equal to 1. I am taking now. Okay? So in the first case, 2, 2 you can take it. You can take it 2, 2. Both you can take now first way. So A is equal to B is equal to 2 belongs to M. It is possible. And A equal to 2 square is not possible. Not possible. Clearly you observe that. So this statement when A belongs to N is false. Therefore A comma A belongs to R. For all A belongs to N is false. The statement whether that it is true or false, that saying that it is clearly false. Now come to question number 2 in that. What is the second question? A comma B. A comma B belongs to R. Next, implies. Implies means like this, dear students. Both the meaning is same. Implies B comma A belongs to R. For example, I am taking A is equal to 4, B is equal to 2. Clearly, A comma B belongs to N clearly, and A is equal to how much? 4. B is equal to 2 square. This is possible. Yes. 4 comma 2 belongs to R. Here I did not mention. In this also 1 comma 1 belongs to R. Okay. But here 2 comma 2 does not belongs to R. Why? Because 2 comma 4 we are getting now here. This not belongs to 2 comma 2 itself. A is equal to B squared. 2 does not belongs to. Okay. 4 comma 2 belongs to. Suppose if you take A is equal to 2, B is equal to 4, A comma B belongs to N clearly, and A is equal to 2, 4 square, B square. Even in this case also, A comma B comma A, 2 comma 4 belongs to, does not belongs to. Why? Because A is equal to B square. B square means what? 16. It is not possible. This belongs to, does not belongs to. 2 comma 4 does not belongs to. Therefore, A comma B belongs to R, and B comma A does not belongs to R. That implies it is good. Belongs to R. Therefore, this statement is this statement instead of this R is false. Okay, dear students. Because of what reason it is false? 2 is equal to 4 square. 4 is equal to 2 square is okay. But it is not possible. Okay. Now, third point I will write it here. Third point means A comma B belongs to R, B comma C belongs to R, then A comma C belongs to R. So for example, A is equal to 16, B is equal to 4. If I take A is equal to B square condition satisfies. So A comma B belongs to N, and A is equal to B square satisfies. So 16 comma 4 belongs to R. This is okay. Next, B comma C. Suppose B if I take 4, C if I take 2, B comma C belongs to also N, and B is equal to C squared. Therefore, 4 comma 2 belongs to also correct. But you can see that A is equal to 16, C is equal to 2, A comma C belongs to N, and A is not equal to C square. Clearly, 16 is not equal to 2 square. That is, 16 comma 2 does not belongs to R. Therefore, A comma B belongs to R, B comma C belongs to R, and so then A comma C belongs to R is false. The statement is false, dear students. Now justification. What is the justification? They are asking to write the reasons, justify your answer. Clearly they are asking to mention the first one, second one, third one. First one is reflexive. Reflexive reason. Statement is true or false. We will justify whether it is true or false. Here 2 comma 2 belongs to R, but 2 is not equal to 2 square now. Therefore, it is a false statement. Two comma 2 belongs to N, maybe. A is equal to B is equal to 2. Belongs to N, but it is not. Next, reflexive symmetry. In symmetry concept, 4 comma 2 belongs to R, but 2 comma 4 does not belongs to R. Why? Because here 4 is equal to 2 square, but here 2 is not equal to 4 square. That is the reason this is also false. If you come to third one, transitivity. Transitive. Thank you. Transitivity. 16 comma 4 belongs to R. 4 comma 2 also belongs to R, but 16 comma 2 does not belongs to R. Since, what is the reason is, 16 we can express as 4 square, 4 can be written as 2 square, but 16 cannot be expressed as 2 square. So even this is also a false statement. I think you are able to understand, dear students, by giving these examples. So till here, question number 6 completed. We'll move on to other question. Question number 7. Let A equal to 1, 2, 3, 4, B equal to 1, 5, 9, 11, 15, 16, and F equal to 1, 5, 2, 9, 3, 1, 4, 5, 2, 11. Are the following true? Are the following true? So in that, what is the first question? F is a relation. F is a relation from A to B. Second one, F is a function. F is a function from A to B. Justify your answer in each case. Justify your answer in each case. A is equal to 1, 2, 3, 4. Similarly, B is equal to 1, 5, 9, 11, 15, 16. And given relation F equal to ordered pairs 1, 5, 2, 9, 3, 1, 4, 5, 2, 11. You know that any relation is subset of A cross B, Cartesian product of two sets. Compulsory, it is a subset. So F is a relation from A to B. Sir, in what way you are saying that F is a relation from A to B? F is, that is justification. Justification, I am giving the answer. Since F is subset of A cross B. If you write A cross B, you are going to get 24 elements ordered pairs. In that, it is a subset. That is the reason F is subset of A cross B. This is only justifying your answer in each case. This is the justification. Because of this reason, F is a relation. So first question completed. Come to the second one. F is equal to 1, 5, 2, 9, 3, 1, 4, 5, and 2, 11. The elements 2 comma 9 and 2 comma 11 are belongs to F and and for two different images are there in F. That means the first element of two ordered pairs cannot be same. That is, the first element can't be same for any two ordered pairs. Then F is not a function. So that is the reason, dear students, it is not a function. Justification of answer also over. Let F be a subset. Of Z cross Z defined by F equal to ordered pair A comma B, AB comma A plus B, where A comma B belongs to Z. Is F a function? Is F a function from Z to Z? From Z to Z. Justify your answer. Similarly, question number 9. Let A equal to 9, 10, 11, 12, 13 and let F defines from A to N, be defined by F of N equal to the highest prime factor of N. Find the a range of f of f, range of f. That is the question, dear students. So one by one we will simplify. First, let us take that question number 8 by taking some examples. We will do it. In that observation, whether it is a function or not, that relation f is given, whether it is function or not. Okay, students. Here, let f be a subset of z cross z defined by f. So, relation is given. Given relation f is equal to ordered pair AB comma A plus B such that A comma B belongs to Z. For example, I am taking, let A is equal to 1, B is equal to 1. Then ordered pair AB comma A plus B will becomes 1 into 1 comma 1 plus 1 2, which belongs to F, obviously. Okay. Next, A equal to minus 1, B equal to minus 1. Then AB comma A plus B will becomes minus 1 into minus 1 is plus 1. Minus 1, minus 1, minus 2. That is also belongs to F. Therefore, for these two, F will becomes, number of elements will take it, but I am taking only for the convenience 2 elements, 1 comma 2, 1 comma minus 2. By observing the relation F, first two elements of relation are same, it cannot be a function. 1 comma 2 and 1 comma minus 2 are same first elements. Same first elements. Same first elements. Then f cannot be a function. F cannot be a function, dear students. I hope you understand it. In what way it will be. Suppose, for example, see that I am taking 2-3 examples. This is a case 1. In the case 2 also we will take it. Let us consider A equal to 2, B equal to 3. Then AB comma A plus B will becomes 6 comma 5 only, no? So belongs to F. A is equal to minus 3, B is equal to same elements but minus you take it. Then AB comma A plus B. Therefore, F equal to 6 comma 5, 6 comma minus 5. Here, in the 2 ordered pairs, 6 has two different images. Or what we can write? Two ordered pairs has same first element in F. Then F can't be, this is the justification, be a function. F can't be a function. Why justification? This is the only justification, dear students. Justification. Okay, now come to question number 9. In question number 9, f of n is the highest prime factor of n. Then find the range. See, suppose if you take the element a belongs to n is equal to 9. If you take, for this 3 into 3, highest factor is 3 only. Three is the highest factor. I am writing. First time I will write it. Next time onwards. Highest prime factor. Highest prime factor. Highest prime factor. N is equal to 10 if you take 2 into 5, both are prime factor in that. Highest is what? 5. 5 is the highest prime factor. N is equal to, if you take 11, 11 itself is a prime number. So 11 is the highest prime factor. Next, n is equal to 12. 12 we can express as 2 into 2 into 3. So 3 is the highest prime factor. Next, n is equal to 13. 13 is the highest prime factor. Therefore, the range of f f of a is equal to, so in that 3, 5, next 11 and 13. So this is the way we can give the conclusion, dear students. Thank you, dear students. I'm going to end the session because in this more 2 sections are there. In that also number of questions are available. So that video number 4 will be, it may be taking by today night itself. I will continue and I will end the completion of relations and functions in this today's class. Not only this one, but also integration is going on. I think third video will come in the another live session in my other channel, Maths with Pandra. Thank you, dear students, for signing off. Jai Hind.